What's going on, everyone? In today's video, we're going to quickly go over the distance and the midpoint formulas in both two-dimensional and three-dimensional spaces, and you're going to find out that it's actually kind of the same thing, but with just one extra step. All right, so let's get right into it. So if you ever want to find the midpoint, you're literally just finding the middle in between those x's and the middle in between those y's. And another way to think about middle, if you have taken statistics before, is kind of like the average or the mean. And so that's kind of what we're doing here. And that's why our formula is the way that it is right here, which is you're taking x1 plus x2 divided by 2, finding the average between the two. And then you do the same thing for the y's. And what you're going to find out is that that gives you the exact middle point in between two coordinates or a line segment, depending on how it's represented. And just a little fun fact, the Cartesian coordinate was named after the French mathematician René Descartes. That's actually where the name Cartesian comes from. So if you ever hear the Cartesian coordinate plane or the Cartesian plane, it's from that guy. All right, so in example 1, we're just asked, hey, we have -3 and 5 for one point, A, and then B, we have 0, 7. These are the endpoints on the diameter of a circle. Remember, diameter of a circle, twice the radius. It's going to be going across from endpoint to endpoint. So now we want to find the coordinates of the center of a circle. So let's say we had some kind of circle here. And let's say that A was here, and then B was here, and we want to go ahead and find the center between the two C. So let's say we have points A, -3, 5, and B, 0, 7. These are the endpoints of the diameter of a circle, and let's go ahead and find the coordinates of the circle. Sorry, the coordinates of the center of the circle. So what that means for us here is that we're basically going to find out, hey, what's the middle in between these x's and what's in the middle between these y's? And in this context, we're going to be given the center of the circle because these are endpoints of a diameter, right? So we have a line segment that cuts through the middle. So if we find out whatever lies halfway in the x right here, and then whatever lies halfway in the y here, we'll find that that coordinate is going to give us that middle point. So how do we do that? Well, we simply just follow our formula. So if we take x1, which we'll call -3, we'll call that x1 and then y1 and then x2 and y2. I'll have -3 my x1, then my x2 will be 0, and I'll divide that by 2. Then my y coordinate would just be y1 plus, let's see here, y2 all over 2. So we're finding the average between these 2 points. So let's go ahead and solve this even further. We have -3 plus 0 over 2. That'll be -3 over 2. And that'll be 5 plus 7 over 2. That'll give us 12 over 2. And if we simplify this, as we always should be, we'll go -3 over 2, comma 6. And this will give us the middle point in between these two if we overlap that circle on a Cartesian coordinate, okay, wherever it happens to be. So that will be -3 over 2, comma 6 for the midpoint of C, okay? So as you can see, all we do is just follow this formula and put in a couple numbers, and as long as you are putting it in your calculator correctly or doing it in your head correctly, you'll find the right answer. Let's take a look at another example. So let's go ahead and find the value of x. And so I know that my midpoint is at -3, 7.5, and that's going to be in between A and B. I'm given some coordinates. I have one missing, my x, and that's exactly what I want to find here. And oftentimes it's helpful to use our Cartesian coordinate plane and plot them out because it's a really nice visual representation of what we're looking at. So if I want to denote, let's say, m, -3, 7.5. So I have -3, and I'll go up to 7.5 here. Okay. And then b is -1, 10. Let me go ahead and denote that as b, -1, 10. M was going to be -3, 7.5. Great. Let me move that over just a little bit so it's not in the way. And then I know that I need to find this missing value, x, comma 5. All right, so I know that it'll be somewhere having a y coordinate here. And of course, this is a midpoint of a line. It's going to be somewhere around this area, but I need to know the exact value. So where is A going to be? Well, if I follow my formula again, I know that the midpoint is going to be equal to my average of x's, then my average of y's. What I have to do is I need to think about what I am missing here, okay? Because I know that my midpoint is going to be -3, 7.5, right? So I know that -3 for x is going to be equal to my average of x's all over 2. And I know that my coordinate for y is 7.5. And you know what? I actually know all my y coordinates because I know that it has 5 for A and then 10 for B. So I'd have 5 plus 10 all over 2. You'll find that this is equal to 7.5. So I actually have a true statement here. That's all good. My x's, on the other hand, it's not so obvious. I know that the midpoint value is -3, but my x1 is the value I'm looking for. That's just my variable x. And I know that y2 is going to be -1. And I'm divide that all by 2. So now I have to do just a little bit of algebra to figure out what my missing variable is. I have to isolate that. So how would I isolate this? Back again to our 2-step equations or 3-step equations, whatever it happens to be. So I'm going to multiply each side by 2 to get rid of that denominator right there. So I'm getting closer to isolating x by itself. So I'm going to have -6 is equal to x plus -1. And if I have a -1 on my right side, I need to get x all by itself. I'm going to end up adding 1. That's going to give me a -5 is equal to x, and that is actually all I need to do. So I know that now my x is equal to -5, and I can go ahead and plot this, because if a is now -5, 5, I can go to -5 and 5 right here. You'll find that is indeed, that looks just right. So a is going to be -5, 5. So hopefully this kind of helps you visually see why exactly we take the average. Because if I know that one of my x values is here and one of my x values is here, well, if I go right here in the middle, the average, I'll find that this right here is going to be the x coordinate of my midpoint. And same thing if I go with y. If I'm going up this far for one of my coordinates and this far for my other, if I find the middle right there, the average, it'll be right there as well, in this case 7.5. So that's why it kind of looks like the average. We take two numbers, we add them together and divide by 2 to figure out where the middle is. So, and that's exactly what we're finding, the midpoint. So hopefully that kind of sheds a little bit of light into why we actually use the very simple average or mean mathematical equation for this. All right, so I hope that sheds a little bit of light into why we use the average formula here, or the mean, why we're adding 2 of the x's and 2 of the y's and dividing both of them by 2 to get our midpoint value, and also how we can get a missing value given that we have our midpoint in some of the other coordinates. All right, in our next video, we're going to take a look at how to do this not just in 2 dimensions, but in 3. All right, so take care, and I'll see you in the next video.